Hey everyone, I'm Karen from Through Inquisitive Kids. In this lesson, we will be diving straight into Chapter 5 of our 8th grade Chinese middle school math lessons series. And you might have seen me if you've been watching these videos from Unit 3. I did the coordinate system there, and now I am going to be doing Unit 5 with you guys. So here we have the introduction to systems of equations. Understanding what systems of equations are and being able to define and determine systems of equations. So here we will be having, this is quite a long unit, we will be having our first lesson here, their introduction, and then we will have two parts to the second lesson, simplifying systems of equations. And then we will have systems of equations in real life, which covers different types of uses that systems of equations can be applied to in word problems. And then we're going to be comparing binary linear equations and linear functions together. And finally, for 5.8, we will be doing multivariable systems of equations. So first, what are systems of equations? Well, that's one of the learning goals for today. We want to understand the definition of systems of linear equations in two variables and their solutions. We also will be aiming to be able to write a system of linear equations in two variables and determine whether a set of numbers is a valid solution. So here's our introduction. Here we have a cow and we have a horse. I'm so tired, the cow says. Are you still tired? For such a big build, he only carried two more than me. So as you can see, they are carrying sacks of stuff from maybe like sand or wheat or something. I took one from your bag and now I have twice as many sacks as you. Really? So think, after listening to their conversation, can you find how many sacks they are each carrying? The definition of systems of equations. Here's your question 1. Let cow carry X sacks and horse carry Y sacks. List two equations out of the relationships from the problem. Okay, so here we're just turning the unknown values into variables. X and Y are unknown values, they're variables that we have set in order to write down multiple equations for this problem. So previously, you might have learned how to apply your knowledge of variables and equations to help you solve simpler equations that might have been used for other word problems. Like you would have one unknown value, you would have an equation, and then you would solve for that. Here we're going to be having multiple equations, all working together. So say you might have multiple equations using the same variables. So let's first set these equations. The number of sacks cow carried is 2 more than that of horse. So that means that x minus y is 2. The cow took a sack from the horse's back, who now carries twice the amount than that of horse. It means that if you add 1 to x, so the original amount that cow had, that's equal to 2 times y minus 1. And now you can simplify each of these two equations and then try to solve for a common solution that works for both of them. Here's another example. Yesterday, a total of 8 people went to the amusement park. A total of $34 was spent for tickets. Each adult requires $5. Each child requires $3. Question: how many adults went and how many children went? Again, pause the video to try to set your own variables and then use those variables to list down the relationships given in the problem. Suppose that there are X adults and Y children. What equations from this can you get? Well, we know that there's a total of 8 people and can either be a child or an adult. So X plus Y is equal to 8. 5x, which means $5 for every adult, plus 3Y, $3 for every child. All of that added together has a total of $34 for tickets. So here's our conclusion. Out of these two sets of equations, so this is to the first problem, this is to the second, how many variables do each of the equations contain? What are the exponents of each of the variables? The answer to these would be 2 variables and degrees of 1. Here's the definition of systems of equations. An equation that contains 2 variables and the degree of the terms of the variables is 1 is called a binary linear equation, meaning that, see, in all of these equations, you have 2 variables, but each of the variables have a degree or power or exponent of 1. So now let's compare. We have two equations right here. X plus 15 is equal to 60. 6 plus y is equal to 45. They're both equations with variables, but this one only contains one variable with a degree of 1. This one here contains 2 variables, each with a degree of 1. Therefore, this first one is a linear equation in one variable, and the second one is a linear function. Let's do some more practice with the definition of binary linear equations and systems of equations. Determine whether the following equation is a binary equation. So we have 1, 2, 3, 4, 5, 6, 7, 8 equations right here. Pause the video to try to sort them. So 1 would be a binary equation, 2 would not be a binary equation, 3 would not be, 4 would not be, 5 would be, 6 would not be, 7 would not be, 8 would not be. So this should be your final answer. So if you're checking, you can go back and to see the answers to each of these different problems. So here's a solution to the last problem. Determining systems of equations. If the original function contains 2 variables and is a whole expression, and if the simplified equation has 2 variables whose coefficients are not 0 and the degrees of the terms are 1. So basically here it says you have to have 2 variables, and each of those variables have to have a degree of 1. Okay. Given that this expression here is a binary equation, what is the sum of m plus n? Well, here's our analysis. From the problem, we know that the absolute value of m has to be equal to 1, and m minus 1 has to not equal 0, and 2n minus 1 is equal to 1. So if we solve this, m is equal to negative 1, and n is equal to 1. So therefore, their sum is 0. The equation is a binary linear equation. The coefficient of the variables is not 0, and the degree of the variable is always 1. Here's some more practice. If this expression right here, x to the 2n minus 1 power plus 5y to the 3n minus 2m power is equal to 7, and that's a binary equation, then what does m and n equal? Well, this means that 2m minus 1 is equal to 1. Using the definitions that we learned earlier, each of the degrees of x and y, which are the variables in this case, have to be equal to 1. So 2n minus 1 is equal to 1. So is 3n minus 2n. So solved, m is equal to 1, n is equal to 1. Think. In functions x plus y is equal to 8 and 5x plus 3y is equal to 34, are the definitions of x the same? Or the numbers of the x the same? What about y? Well, the answer is that the variables x and y are respectively representing the same values in both equations. So x and y must satisfy equations x plus y equals 8 and 5x plus 3y is equal to 34 at the same time. By combining them, we get this system of equations. So here's a knowledge key point from what we just went through. There are 2 variables in a system of equations. The terms containing each variable have a degree of 1. There are 2 equations called the system of linear equations in 2 variables. So that's the longer name for a binary linear equation. Note, the same variable in each equation of the system of equations must have the same value. So it means that For example, I can't have 2 and 6 for x and y up here, and then have 3 and 4 for this down here. No. So x and y in both of these, if this is grouped up together in a bracket, it means that they represent the same values. Example 2. Which of the following system of equations is a system of linear equations in two variables? So check. The answer is B. Why? Well, for A, x, y. If you have x, y added together, that would be fine. But if you multiply them together, that's actually a different type of variable. So it doesn't work if you have two variables put together. Okay, now let's look at C. Why would C not be a system of linear equations in two variables? Well, it has more than two variables. It has three. Remember, we should just have x and z, x and y, or y and z. We shouldn't have x and y and z at the same time. Okay, now what about D? Well, this has to be a whole expression. And remember, last year for the 7th grade math lessons, we covered that a whole expression requires for the denominators of a fraction to be a known number. So you can't have a variable on the denominator right here, meaning that B is the only qualifying system of linear equations in two variables. Note, this right here is also a system of linear equations in two variables. Right, because for the second one, 3x is equal to 4. Well, that one equation only has one variable, but this altogether has two variables. Is the following system of equations a system of binary equations? So just determine and judge and check whether each of these follow the expectations for a system of equations, a system of binary equations. Well, this one is, but this one has three variables, so it is not. This one is, and this one here, the variable is appearing in the denominator. So x and y, again, same problem as before. It has to be a whole expression, meaning that there can be no variables on the denominators of a fraction. Okay, and here 5 is also qualified. Solutions of systems of equations. Question. Does x equal 6 and y equal to satisfy x plus y is equal to 8? What about x is equal to 5, y is equal to 3? Or what if x is equal to 4 and y is equal to 4? Can you find other values of x and y that satisfy the equation x plus y is equal to 8? So think about that for a moment. Is there any other values? Well, you could do 8 plus 0 or 7 plus 1, or even you can go into decimals. Does x equal to 5, y equal to 3 satisfy 5x plus 3y is equal to 34? What about x is equal to 2, y is equal to 8? So again, in systems of equations, it says systems, so it's in equations, meaning that it's not just one equation you're working with, but a group. So if you have a solution to it, it must apply to each of the equations in that system. So x is equal to 2, y is equal to 8. This second set does not qualify for this second equation, but it does for the first. But x is equal to 5, y is equal to 3 qualifies for both, meaning that x is equal to 5, y is equal to 3 is a valid solution for this entire system of equations. The value of a set of variables that fit a linear equation in two variables is called the solution of the linear equation in two variables. Here's an example. In x equals 6, y is equal to 2 is the solution of x plus y is equal to 8 and can be recorded as here. So again, it is a group. You don't have x is equal to 6 separately, then y is equal to 2. So whenever you solve a equation, always write it like this to show that it is a group. It is a very good habit as you start doing more and more complex math. Does x equal to 5, y equal to 3 satisfy this expression? Does x is equal to 5, y equal to 3 satisfy this next expression? The common solution of each equation in a system of equations is called the solution of the system of equations. Pretty straightforward, huh? For example, this is a solution to this. So again, you have both of these values grouped together with brackets. Example 3. If x is equal to -2 and y is equal to 3, and this is a group of solutions, and that's the solution to x minus k, y is equal to 1, the value of k is what? Well, you already know the values of x and y, so why not just substitute this into here? So after substitution, you will have the solution of k is equal to -1. For the following problems, please find the system of equations and solve to find the solution of the problem. Example 4. The processing of a certain product requires 2 processes. The first process can complete 900 pieces per person per day, and the second process can complete 1,200 pieces per day. There are 7 workers participating in these 2 processes. How should manpower be arranged? Can the number of pieces completed by the first and second processes be equal every day? Pause the video and use system of equations to help you solve this problem. Our first step is to establish variables. Let the first process be arranged for x workers, and the second process is for y workers. And out of this, the second step we do is to write out the equations. X plus y is equal to 7, 900x is equal to 1,200y. And this is really the hardest part, I feel like, because once you got the equations down, it's really just math, like plain on math. And all you have to do is just solve for the values and you're done. Answer. Assign 4 workers for the first process and 3 workers for the second process. Again, as you can see, I answered in a full sentence. This is what your answer should be like for your for whatever you're doing too. So you should always strive to answer in full, complete sentences. Class summary. Introduction to systems of equations. This is what we learned today, and it is the main topic for today. So in here, I hope the 2 things that I want you to walk away from this lesson is the definition of systems of equations and solutions of systems of equations. The 2 skills we learned today is to understand the definition of linear equations and 2 variables and their solutions, and as well as being able to write a system of linear equations and 2 variables, and determining whether a set of numbers is a valid solution to that linear system of linear equations and 2 variables. Thank you so much for watching through Inquisitive Kids. If you enjoyed this video or found it helpful, please try to click the subscribe button and to click the thumbs up button down below, and click the notification bell for more of Through Inquisitive Kids content coming right up. Stay tuned for the next lesson.